Um, what happens here is that you see a reflection about this line right here, y equal x, and all of the x values are switched, x and y's. And this is the reflection that you're going to see. If you do a properly drawn inverse graph, it should be a reflection about y equal x. Okay, let's practice a couple of these. First thing we're going to do is we're just going to take an easy one here, y equal to 1 minus 2x over 5, and here y is equal to 2x over 1 minus x. I want you to switch the variables and solve for y. So if I switch x and y around, I'm going to get 5x equal to 1 minus 2y, subtract 1, 5x minus 1 equals negative 2y. What's y going to be equal to? 5x minus 1 over negative 2. How many got that? Now, I think it's right, but I'm not so sure. So here's what I'm going to do. I'm going to put a 1 in for x here, a 1, and I get 1. 1 minus 2 is negative 1 over 5, or negative 1/5. Now I'm going to put a negative 1/5 in for x. And what should I get if it's an inverse? I should get a 1. Let's see. What is 5 over negative 5? Negative 1. So you get negative 1 minus 1 over 2. Is that negative 2 over 2? Negative 2, I mean? Yep. So is that equal to 1? It works. This is easier. Put a 0 in. 0, you get 1/5. So if I put in a positive 1/5 this time, 5 over 5 is 1 minus 1, which is 0. So it works. All right, this other one, a little trickier, but not impossible. X is equal to 2y over 1 minus y. Cross multiply x times 1 minus y equals 2y. X minus xy equal 2y. Now, what are you going to do next? This is the part people have trouble with, but not you. What are you going to do next? Claire, what do you think? Ben will help you if you get stuck. That's not too bad. What are we solving for? What are you solving for? Nope. Solving for y, right? We want to solve for y. So let's get those two together. X is equal to 2y plus xy. Are you okay with that? Now what do you want to do? You're solving for y, so what do you want to take out? Not a 2 yet. Take out the y, so now you have 2 plus x. Now is it easy to solve for y? Just divide both sides by 2 plus x. Did I go too fast on that one? So all you're doing is you're solving for y. So we're going to have to get, you're going to have to get these y's together on one side, factor out the y, and then divide out this. And so this is my inverse function. So if we put, what would we want to do? Put in a negative 1, so you get negative 2. 1 minus a negative 1 is 2, so this is going to be negative 1. So if I put in a negative 1, I'm going to get negative 1 over 2 minus 1 is negative 1. And so it worked out. Put in negative 1, get a negative 1. That one's kind of interesting. That's an interesting spot on the graph. All right, so with graphs, we talked about the idea of switching the coordinates, getting the inverses. Notice that this one, the inverse is going to be here. You go 0, 0, and then this is going to be tilted this way. And so what will happen is that this is your y equal x line. And so when you do that, you get the inverse graph here. And is the inverse of this one going to be a function? Is the inverse of this going to be a function? No, that's the horizontal line test. Okay, and domain and range are switched. We talked about that. I think all this is pretty good. Talked about the graphing of these. So here's what we're going to do. You started a few of these. Let's go to assign all of these inverse ones through the end here. Let's see if we can do these three in class today before you go. 21, 22, and 24. Where A and B are constants like 4 or 5, and you're going to remember that f of x is the same as y. You're going to find the inverse of these. So let's do this one together. What do you do first to find the inverse of this? Switch y's and x's around. And now we solve for what? For y. So you get x minus b equals a times y. So what's y going to be equal to? X minus b over a. And do you see why they don't want a equal to 0? Smart. They're thinking ahead. You try that with 22 and 24.